These are kind of the themes that are going to be tested. You will need to show that you are able to name angles. Right, I think you know how to name angles now. We can use three letters to name angles, in which case these have to be capital letters. Or if we have numbered our angles at some vertices, we can just take advantage of that. Now we should be able to classify triangles, give like the types of triangles, and then the properties of the triangles, the theorem of Pythagoras, it's in your syllabus, then area of a triangle. So make sure that you master all these things. Triangles can be classified using sides, and then they can be classified using angles. So let's use sides first. Give me one.
Scalene.
A scalene triangle, right? What is a scalene triangle? Yes. Right, so a scalene triangle has no sides equal, right? Please take note of that. A scalene triangle has no equal sides. So that is number one. Give me another one, Nikita.
Equilateral triangle.
Equilateral. What is an equilateral triangle?
Triangle with
All sides are equal in an equilateral triangle. Right, another one. A third one. Yes. Isosceles triangle, right? And what is an isosceles triangle? Only two sides are equal. Okay, so if no sides are equal, then it's scalene. If two sides are equal, then it's isosceles. And if all sides are equal, then it's equilateral. Right, now classify triangles using angles. Yes, Matthew. So there is what we call an obtuse angled triangle, right? And what is an obtuse angled triangle?
All angles. One angle.
One angle is obtuse. Is it possible in any case that we can get two obtuse angles in one triangle? No. So an obtuse angled triangle should have one of its angles obtuse. Okay, so that is number one. Another type? Yes. A right angled triangle. What is a right angled triangle? One of the angles should be 90 degrees. Is it possible to get a triangle that has two right angles? No. Okay. So that is number two. The third one? Yes. The acute angled triangle. And what does that mean? All the angles are acute. Then for the properties of the triangles, this one should be very popular. We have been using it, I think, already. The sum of the interior angles of any triangle should be 180 degrees, which means angle A plus angle B plus angle C should give us 180 degrees. And should you find yourself using the property that the sum of the angles is 180 degrees, you can write the reason in short like this. Remember, we are doing geometry. So you can simply say sum of angles of a triangle. That will be fine. Or you can go on and say sum of the interior angles of a triangle is equal to 180 degrees. That is still fine. But that is acceptable. All right. Then a property that I think is not used by many people is the second one. It says the exterior angle of a triangle is equal to the sum of the two opposite interior angles. Does it make sense?
Yeah.
It does not make sense. Okay, so here's a diagram here. Tell me which angle here do you think is exterior? Yes, that's one. So C1 is exterior because you know the meaning of exterior, right? So now tell me if this one is exterior, which one is interior? Because the opposite of exterior is interior. So which one is interior? C2 therefore is interior. But do we agree that angle A and angle B are also interior? But relative to this situation here, These are interior but opposite. Do you see that? So we can refer to this one as interior opposite. This one is also interior opposite, or you can say opposite interior. It doesn't matter. So this is exterior, this is interior. This is therefore interior opposite or opposite interior, and that is also interior opposite. And the theorem, right, I'll use theorem, but this affects, the theorem says if you take the two interior opposite angles and add them up together, they will give you the same value as the exterior angle. If I call this one theta, this exterior one is theta, and I call this one beta, and I call that one alpha, and I call this one omega. Right, can somebody give me an equation relating theta? Listen carefully. I want you to give me an equation that relates theta to omega, and give me a reason.
Theta is equal to, what's that one? W1?
Omega?
Omega is equal to 180 minus omega.
That's correct. So, in other words, theta plus omega should give us how many degrees?
180.
So theta plus omega should give us 108 degrees. What is the reason for that? What is the reason? Why do they add up to 180 degrees? These are angles on a straight line, right? So these are angles on a line. All right. Right, now I want you to give me an equation connecting theta, beta, and alpha, and give me a reason for that.
Alpha.
Yes.
Beta plus alpha equals beta.
Beta, okay, so angle beta plus angle alpha, these two added together should give us the same value as theta. All right, well done. And your reason is all this, right? Because the exterior angle of a triangle can be shown to be equal to the sum of the two opposite interior angles. We can prove that anytime. But instead of writing the whole paragraph, you can just shorten it and say exterior angle of a triangle. We will know that you mean this, okay? Right, so we are saying this angle there is exterior. Obviously, this then is interior. This here is also interior, but relative to theta, that is interior opposite, or opposite interior, because interior is here. So if interior is here, then that is opposite interior. And this is also opposite interior. So let's call this one alpha, and let's call that one beta. Right. So it is saying the exterior angle theta should be the same as, or should be equal to, the sum of the opposite interior angles. Okay. And you are not going to say that and not give a reason. You will need to give a reason. And your reason in this case will be exterior angle of a triangle. Then the other thing, the other important thing, you are given here a triangle. This is very important. You need to look at this thing critically. So you are given a triangle. And the sides are known. We know the length of this side is 9, that one is 14, and this one is 17. Right. Did you know that the longest side of a triangle will always be opposite the largest angle?
Yes.
Because we will need this kind of information in grade 11 when we do the sign formula and we deal with what we call the ambiguous case. Okay? So the longest side must be opposite the biggest angle or the largest angle in a triangle. So you can tell A is the largest angle in this triangle, followed by which one? The next one should be angle C, right? Angle C should be larger than angle B. Why is angle C bigger than angle B? Because the opposite side for angle C is larger than the opposite side for angle B. Do you see that? Okay, so that's a property that you need to know. And I think this is the right time to learn this kind of thing. Okay, then something about isosceles triangles. Remember, isosceles means two sides are equal. It says in an isosceles triangle, the two angles opposite the equal sides are equal. Right. We normally refer to this as a base. So that is the base of the triangle, right? And so some people refer to this one here as a base angle. So this is a base angle, and that is also a base angle. I think it makes sense. You understand why they call them base angles, right? And so you'll hear people talk about base angles of an isosceles triangle are equal, right? Do you see that this side and that side are equal? Right. Now, this angle y lies opposite that side, right? And the other angle y lies opposite that side. So do you see that these angles are actually opposite equal sides? It makes sense, right? Right. So if you are going to say angle C is equal to angle B, which means these two angles here, which are obviously equal to y, then what reason are you going to give for me? I no longer want you to say base angles because I think I'm tired of that. So don't say base angles. You can say that, I won't penalize you, but I won't be happy. Right, so what do you say now? Why are we saying these two angles are equal to each other? This is because the angles are opposite. These are angles which are opposite equal sides. So the thing is, guys, angles opposite equal sides are equal. So angles opposite equal sides are equal. Therefore, angle C is equal to angle B. The reason is because these two angles actually are opposite equal sides. But if you say that, you need to continue and tell me which sides are actually equal. So which sides are equal here? AC is equal to AB, right? Please copy that down. So we will say angle C is equal to angle B, which is Y. And the reason is because these are angles opposite equal sides. And then we name the sides. We need to name the sides. This one says, in an isosceles triangle, the two sides opposite the equal angles are equal. This is just the same thing that we did. So we are saying, if I tell you this, if I tell you that, for instance, this is 30 degrees, and this is also 30 degrees, maybe this is P, that is Q, that is R. If these two angles are 30 degrees each, what conclusion can we make regarding PQ and PR? What can we say about PQ and Q and PR? Yes.
They're equal.
So PQ should be equal to PR, right? Why are we saying that? So we are saying this side should be the same length as that side. And what is the reason? Yes. Right, good. So these are sides which are opposite equal angles. And you can go on and tell me that angle Q is the one that is equal to angle R, which is 30 degrees in this case. So that would be my reason. So if angle Q is equal to angle R, then side PQ should be equal to side PR. And that is because those are sides which are opposite equal angles.